So welcome back students to the course of Computer Graphics and Multimedia. So CAPOL 208. So I'm SENTHIL SELVAN. I'm handling this Computer Graphics and Multimedia. So this is unit number 2. So this session, we are going to see about the output primitives circle generating algorithm. So previous sessions we saw about the line fitting algorithm, that is DDA, and so resonance line algorithm. So this session we are going to see about circle drawing algorithm. So it's a midpoint circle drawing algorithm. So the basics of circle. So first we'll see the basics of circle. So a circle is defined as the set of points that are all at a given distance r from the center position xc, yc. So the position may be 0, 0, or the position may be at any point in the plane. So that is xc and yc. So r is the radius of the circles. So for any circle points xy, so the distance relationship is expressed by this formula. So usual formula is x square plus y square equal to r square. But here, so we'll choose some coordinate for x, y. So that's why x minus xc square plus y minus yc whole square equal to r square. This formula is taken here. Use these equations to calculate the position of points on a circle circumference. So we have to find the point in the boundary circle circumference, the intermediate points we have to find. So step along the x-axis in unit steps from xc minus r to xc plus r, and calculating the corresponding y. Y equal to yc plus or minus root of r square minus xc minus x the whole square. So it involves considerable computation at each step. The spacing between the product pixel position is not a uniform. That is a problem here. So initially, to eliminate the unequal spacing, so calculate points along the circle boundary using polar coordinates. So that's why they are going for polar coordinates r and theta. So x equal to xc plus r cos theta, y equal to yc plus r sin theta. So using a fixed angular step size, a circle is plotted with equally spaced points along the circumference. So still computation, it will take more times. So can be reduced computations by considering the symmetricity of the circles. So actually we'll calculate the one quadrant of the circle. So rest of the three quadrants value will be generated from that. So shape of the circle is similar in each quadrant. So quadrant 1 if you find, so quadrant 2, 3 you can easily identify that. If you got 3, so quadrant 2 you can identify that. If you got 2, quadrant 4 you can identify from those points. So if first quadrant is determined, second, third, fourth quadrant of the xy plane so can be generated easily. So that is the logic here. So note that there is also symmetricity between the octants. So circle sections in adjacent octants, so within one quadrant are symmetric with respect to the 45-degree line dividing the two octants. So by using this logic, so they frame the midpoint circle algorithm. So now we'll move to the midpoint circle algorithm. So what actually here they are doing is, so this is the steps we have to follow. So in the algorithm, so sample at unit intervals and determine the closest pixel position to the specified circle path at each step. So what we done, so in the line algorithm, similar kind of things we are doing it in, generating one quadrant of the circle. So x value will increasing, so y value will keep in the radius value initially, so yk, then yk minus 1, or we have to stay back in yk. So like that we have to do it in the circle algorithm. The given radius r and the screen position xc, yc they'll give. Sometimes they'll start from the origin, they will draw the circle, or sometimes some xy coordinate value they'll give. From there, so based on the r value, they'll start fixing, that is predicting the pixel position. So x value will increase So like the previous line algorithm, so pk value pk plus 1 we are having it. So if it is less than 0, yes, we will stay back in same position. If it is greater than 0, so yk minus 1 will reduce the y coordinate positions. So first step in our algorithm is to calculate the pixel positions around a circle path centered at the coordinate origin, so 0 comma 0. Then each calculated position x comma y is moved to its proper screen position by adding so xc to x and yc to y. So generating the circle section from x equal to 0 to x equal to y. So in the first quadrant, the slope of the curve so varies from 0 to the negative minus 1. So take unit steps in the positive x direction so over this octant. So use decision parameters so to determine so which of the two possible pixel positions in any column is vertically closer to the circle path. To apply the midpoint method, so define a circle function. So initially, so f of xy equal to x square plus y square minus r square. This is the general equation for circle. And at any point xy on the boundary of the circle with radius r satisfy the equation f circle x comma y equal to 0. If the point in the interior of the circle function is so negative. If the point is outside the circle function is positive. So in that case only we have to calculate. So as per the formula, which is less than 0 is inside the circle boundary. If equal to 0, which is on the boundary, so more than 0, it's outside the circle boundary. So we have to consider so this two parts. The above tests are performed for the mid portion between the pixels, so near the circle path at each sampling step. The circle function is the decision parameter in the midpoint algorithm. So step up, so incrementally, so calculations for this function as in the line algorithm. So this is see the figure here. So we'll increase the x position. So but as usual, so y position we have to consider either yk or we are coming towards yk minus 1. We are decreasing the y value. Then only we'll get a curve in the first octant. If we got the first octant values position, from that we can find out the rest of the octants 2, 3 and 4. Assuming that the pixel at xk, yk, next need to determine whether the pixel is closer to the circle, so which is xk plus 1 yk or xk plus 1 yk minus 1. We have to decrease it. So based on the pk value is so less than 0, we'll stay back. It is greater than 0, we'll decrement the y pixel portion. So x is always increasing. So that is a slope is less than 0. If it is more than 0, so we have to change it to identify in the next octant 2. So y value will keep on what decreasing. So x we have to identify. Evaluate the decision parameter at the midpoint between these two pixels, which is pk equal to xk plus 1. That is y actually x actually we are increasing. So but y is the midpoint we have to take. Yk minus 1 by 2. So we'll apply in the circle algorithm, which is x square plus y square minus r square. Just apply this, we'll expand this. So finally we will get this equation. Evaluate the decision parameter at the midpoint between these two pixels, which is xk plus 1 whole square yk minus 1 by 2 the whole square minus r square. If pk is less than 0, this midpoint is inside the circle. The pixel on scan line, so yk, which is so closer to the circle boundary. Otherwise, the midpoint position is outside or on the circle boundary. The pixel on the scan line, which is yk minus 1, we have to reduce it. So if it is less than 0, we have to keep in the same position yk. If it is greater than 0, we have to decrease the yk minus 1. So midpoint circle algorithm successive decision so parameters are obtained so using so incremental calculation, that is pk plus 1 equal to The next position xk plus 1 plus 1. But what about yk plus 1? So minus half. So we have to apply this in the actual circle function x square plus y square minus r square. So that pk plus 1 equal to pk plus this equation we'll obtain 2xk plus 1 plus y square x square plus 1 minus y square k minus yk k plus 1 minus yk plus 1. Where yk plus 1 is either the next point, the pixel position is either yk or yk minus 1 depending upon the pk value, the decision parameter. So now, so how to calculate the initial parameter, decision parameter value? So at that point, x value is 0, so y is our r value, radius value. So now you apply this in the circle equations, which is 1 comma r minus 1 by 2, because midpoint circle algorithm be chosen. So 1 comma r minus 1 by 2. So 1 is which is the next x position, but y only we have to decide. So y plus r minus 1 by 2 whole square minus r square. X is 1, so y is r minus 1 by 2, and r is still r as it is. So p naught is 5 by 4 minus r, which is nothing but 1 minus r. This is the initial parameter, decision parameter we have to take. So based on this, we'll decide either we have to stay back in yk or we have to decrement the y value. So this is the midpoint circle algorithm. So for what I told, so this is a summary of the midpoint circle algorithm. So input is given here. So r value and the circle center. So that is xc, yc, which is calculated. Then set the coordinate for the first point on the circumference of the circle centered on the origin as x naught, y naught equal to 0, comma r. Calculate the initial value of the decision parameter as p naught equal to 5 by 4 minus r, which is nothing but 1 minus r approximately, at every step xk position. So starting from k equal to 0 in the iterations, first iteration, perform the following test. If pk value is less than 0, the next point on the circle centered 0, 0 is xk plus 1 minus yk, and the decision parameter pk plus 1 equal to pk plus 2 xk plus 1 plus 1. If you are not started with the origin, so then xk, that position value will change. Otherwise, the next point along the circle is xk plus 1, so yk minus 1, yk value we have to reduce, and the decision parameter pk plus 1 equal to pk plus 2 xk plus 1 plus 1 minus 2 yk plus 1, where 2 xk plus 1 is equal to 2 xk plus 2, and 2 yk plus 1 is nothing but 2 yk minus 2. Determine the symmetric points in other 7 octants. So where we have to stop it, if x and y point where we are getting the same pixel position, that point we have to stop. That means we identified the first octant's values, pixel positions. So rest of the pixel values, octant values, we have to calculate from the obtained value. So move the each calculated pixel positions on the circular path centered at xc, yc, and plot the coordinate values as x equal to x plus xc, y equal to y plus yc. So we have to repeat the steps 3 to 5, so until x, y pixel values will get same, or if x crossed more than y, we have to stop this process. So how this is working? So with an example problem, we can see that the given center coordinate point is 0, 0, and the radius value is 10 given here. We have to find the first octant. So in the circle, we have to find it. So initially the center point is given as 0, 0. The radius of the circle is 10 is given here. Assign the starting point coordinates. X is 0, y is actually 10. Yes. And calculate the value of the initial decision parameter. So which is p naught equal to 1 minus r, which is 1 minus 10, that is minus 9. So it's a negative value. So x we have to increase, y we have to stay back in the same position, which is 10 actually. So y will increase, that is to 1, x is 1, y stay back because the initial decision parameter value is negative. So 10. So next pk value we have to calculate. Pk plus the formula is given there, 2xk plus 1 plus 1, which is minus 9 plus 2 into 1 plus 1, which is minus 6. So second iteration, the pk value is also still negative. So that means, which means, see, we have to repeat this process. And x value is increased to 2, and y we have to stay back in 10 itself. So 1 comma 10, 2 comma 10. So now this case we have to calculate the pk plus value, that is so as per the formula we have to calculate it. So minus 6, so I will go to the formula. So minus 6 plus 2 into xk plus 1, that value is there, which is 2 into 2, 4 plus 1, 5 we got it. So minus 6 plus 5 we are getting, so minus 1 here. So next iteration also, so we got a negative value, so which means x will increase, but y still we have to stay back in yk itself. So now we are calculating, so that xk value is changing here. So that is the pk decision parameter value, we are getting a positive value in that case. So x is increasing, y we have to decrease it, and the pk plus 1 value equal to previous pk value, which is 6. Sorry, minus 1 we got it. So minus 1 plus 2k xk plus 1 plus 1 minus 2k yk plus 1. So that is, so we got 7 here. So 7 minus 1 is 6 we got it. So here the pk decision parameter value is so positive value. So which means, so we have to reduce the y value, that is from 10 to 9 we got it. X is always keep on increasing in each interval. And now we have to calculate the pk plus value. So as per the formula, pk plus 1 equal to pk, which is 6 plus 2 xk plus 1 plus 1 minus 2 yk plus 1, we got minus 3, a negative value. So if we got a negative value, so we have to stay back in the same position, that is yk. Yk is 9 in the previous iteration. So now we have to use the same yk value, but x is keep on increasing, 5 comma 9. And as per the formula, so minus 3 plus 2 xk plus 1 plus 1, so we got 8 here. So pk plus 1 value. So in the next iteration, 8 is carry forward, so which is a positive value, which means, so we have to decrease the y value from the previous yk. So which is 9, now it will become 8. 6 is always increase, 6 comma 8. And the next value is 5. So 6 comma 8. Then next time, so I calculating, we got 5. So which means, so we have to increase the y value, we have to decrease, we have to increase the x value, we have to decrease the y value. So 7 comma 7 we got it. So we have to stop the algorithms as per the rule. So once x, y pixel value same or x crosses y, so we have to stop the algorithm. So these are the pixel positions. Initially we started with x0, y is our radius value. Then x increased, y, so we stayed back the same position. X increased, we stayed back the same position. So x increased, we stay back the same position. Then x increased, y is decreased. So x is increased, so y stay back the same position. So x is increased, y is decreased. And next round 7 comma 7, x increased, y is also decreased. At which point we are decreasing the y value. So pk value is so positive, so we are decreasing the y value. Otherwise, we'll stay back in yk itself. If it is negative, we'll stay back the same position. So here also, so smooth curve, so we are not getting it. Some jag curve only we are getting it. So similarly, we identified for the first octant, which is 0, 10, 110, 210, 310, 4, 9, 5, 9, 6, 8, and 7, 7 we'll get it. So similarly, so for octant 2 is 0, 10, minus 110, minus 210, minus 310, minus 4, 9. Similarly for octant 3, for quadrant 4, so we have to identify, because it's a symmetric object. Circle is a symmetric object. So if we got the pixel values for quadrant 1, so quadrant 2, 3, quadrant 4, we can easily identify that by changing the so position. and like that. So rest of the important values also we can identify it. So using this midpoint circle algorithm. So that's all about the midpoint circle algorithm. So just to take the general circle equation x square plus y square minus r square. Then for the first quadrant we are identifying it. So it's a midpoint circle algorithm. That's why we applied xk plus 1 for x and for y. So yk minus half we took it. We applied in the equations. We identified pk plus 1 addition parameter. So based on that parameter, we'll decide either we have to stay back in same y position or we have to decrease the y pixel position. X is keep on increasing. So if we'll go for different quadrant, so in that case, so the calculation will what vice versa it will go. So y value will keep on increasing. So x we have to identify in quadrant to 2 we have to identify that. So like that it will change. So based on the quadrant we are choosing. So that's all about this circle algorithm. So that's all about the unit 2 also. In unit 2, we saw about input devices, output devices, software functionalities, and standards, and the output units like line circle and all. We saw that. So that's all about unit 2. Thank you.